Hello, my name is Mr. Wilke, and today we're going over solving quadratic equations. We're reviewing for Algebra 1. So let's start with number 6. This says -6 plus 2 equals 5x squared. So the first thing we always do is what? That's right, we need to set one side equal to 0. So I always find it easiest to keep the a positive, so let's add 6x, subtract 2 from both sides, so we'll end up with 0 equals 5x squared plus 6x minus 2. So remember, quadratic formula states if ax squared plus bx plus c equals 0, then x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Okay, so what's a, what's b, what's c? A is 5, b is 6, c is -2. Next thing I like to do is I like to check the discriminant. So if I check the discriminant, which is the square root of b squared minus 4ac, and it's negative, well, if the discriminant is negative, there's no solutions. If the discriminant is a perfect square, I can factor it. So let's just plug in square root of 6 squared is 36 minus 4 times 5 times -2. So 20 times -2 is -40. 36 minus a -40 would be the square root of 76, which there's no perfect square there, right? Well, there's a perfect square and 74 goes in there, so that's 2 on the outside, 19 on the inside, so 2 root 19. For those of you who like to simplify your radicals, like I do, root 76 is 2 root 19. Okay, so not a perfect square, can't factor it. Two solutions, because discriminant's positive, therefore, what do? We plug in the rest of our quadratic formula. So x equals the opposite of b, opposite of 6 is -6, plus or minus, well, I already know what the square root of b squared minus 4ac is. It's 2 root 19. All over 2 times 5. Now, if I want to simplify this, I know 2 goes into both of those, so I can rewrite this as -3 plus root 19 over 5, -3 minus root 19 over 5. Okay, does everybody see what I did? I just canceled or reduced out the 2. So 6 over 2 is 3, 2 over 2 is 1. We don't need the leading 1. So there we go. Now, if we want exact answers, that's it. If we want approximate answers, we have to take the square root of 19, so -3 plus root 19 over 5. If you work that out on your calculator, you should get x is approximately 0.3. Over here, x is approximately -1.5. And there we go. Any questions? We're good? Okay, so there's exact answers, approximate answers. All right, now let's do some internet magic and we'll go to the next problem. And there it is. So we've got number 7 up there. 285 equals 4x squared minus 111. Now, we could set one side equal to 0, try to factor it, or we could set one side equals 0, try to factor it, or we could probably use a square root since there's no x term, which is what I'm going to do. So let's get rid of the 111 by adding 111 to both sides. We've got 396 equals 4x squared. So now we've got to get rid of the 4, divide both sides by 4. 396 over 4 is 99 equals x squared. So let's take the square root of both sides. Square root of x squared is x. Square root of 99 is plus or minus, right? Plus or minus root 99. Can I simplify that? There's a perfect square in there. 9's a perfect square. So 9, square root of 9 is 3. So we're going to have plus or minus 3. We'd be left with 11, and that's x equals plus or minus 3 times root 11. If you want to, that's the exact answer. If you want the approximate answer to the nearest tenth, 3 times root 11 is going to be, x is approximately plus or minus 9.9, or x is negative 9.9, x is positive 9.9. Does everybody see how we did that? We got 4x squared equal to that, divided square root both sides. Remember, you got to have the plus and minus, 2 answers, plus or minus 3 root 11, or plus or minus 9.9. All right, I think that's it for solving quadratic equations, but let's go to page 4 of your assignment, and again, some magic. And magically, we're at number 8, where we need to simplify using rules of exponents. Now on your paper, it gives you the same question twice. So one of them is going to be using rules of exponents, one of them is going to be using expanded form. I'm going to let you work on expanded form because you're going to get the same answer. And I'll talk about it a little bit as we go, but let's start out. Well, where should we start out? Let's simplify this first. I'm going to simplify that first too. So I'm going to end up with negative 3x squared. Now, if it helps, we can rewrite this z to the positive 4. To get rid of the negative exponent, you switch from the numerator to the denominator. Over here, what do we do with power to a power? Well, we have to multiply. So 5, this would be 5 to the first, to the second would be 5 to the second. So 5 to the second. X to the third to the second, we should know is x to the sixth. And if you want, remember you add exponents, or we could say x to the third times x to the third is clearly x to the sixth. So 5 squared x to the sixth over z squared squared is z to the fourth. All right, now all we have to do is multiply. Well, 5 squared is 25 times negative 3 is negative 75. X to the second times x to the sixth. Remember, that's x times x, that's 3, 4, 5, 6. So that's x to the eighth. Oh yeah, we just add the exponents. 2 plus 6 is x to the eighth. Z to the fourth times z to the fourth. Again, add the exponents. We get z to the eighth. So we have negative 75 x to the eighth over z to the eighth. All right, if you did it with expanded form, which Here's a little bit of how to do that. Okay, you should end up with the same answer. So rules of exponents is the shortcut. That's what you're going for. You want to be able to use the rules of exponents. If you still need expanded form, do it. If your teacher asks you to show them expanded form, do it. But this way, much shorter. Memorize those rules of exponents, okay? Cool? All right, let's move on to, and there's number 9. So number 9, it looks like we're simplifying radicals. So we've got -6 times square root of 15a times 2 root 6 minus 5 root 40a. Now, we can't simplify anything yet because, well, at least we can't subtract because we have to have like radicals. Well, do we have any perfect squares? No and no, but I can multiply everything together. Multiply what's outside the radical, multiply what's inside the radical. So I'm going to get -6 times 2 is -12 times 6 times 15 is 90a minus 5 times root 40a. Still aren't like radicals though. But there's a perfect square here and there's a perfect square there. What's the perfect square that goes into 90? 9. What's the perfect square that goes into 40? 4. And what do you notice is going to be left over? Cool. Okay, so let's do this. -12. And here, let's just do it. 9 times 10a minus 5. 4 times 10a. We can even do this. -12 root 9 root 10a minus 5 root 4 root 10a. Perfect square, perfect square. We're gonna have like radicals. So -12 root 9 is 3, so we'll have -36 times square root of 10a minus square root of 4 is 2. -5 times 2 is minus 10. And then just combine. -36 minus 10 is -46 times the square root of 10a. And that's it. Now, this still ugly, but so much nicer than that, right? This is why we simplify, okay? This is way easier to look at, way easier to figure out what it might be than something like this, okay? So simplify, combine, and we're good. All right, we got one more problem that I'm going to go to, and it is problem number 10. All right, so let's look at problem number 10. Problem 10 says, identify all important features of the quadratic function, including the x-intercepts, axis of symmetry, vertex, and y-intercept. Sketch the graph. All right, so we're looking at this quadratic function here, y equals 2x squared minus x minus 10. Let's figure out what's the easiest to figure out first. Well, easiest is always the y-intercept. The y-intercept is right here. If x were 0, y would be -10. So y-intercept 0, -10. I'm going to put a point right there. Okay? Vertex. Do we remember how to find the vertex? The vertex is x equals -b over 2a. Okay, so if x is -b, be -1 or 1 over 2 times 2, which is 4. So the vertex is 1/4, comma. How do we do that? We plug it in, right? So let's plug in. Y equals 2 times 1/4 squared minus 1/4 minus 10. Well, 1/4 squared is 1/16 times 2 is 1/8. 1/8 minus 1/4, which is 2/8. Oh. So 1/4, 1/8 minus 1/4, or 1/8 minus 2/8 would be negative 1/8, minus 10 would be negative 10 and 1/8. Now, that's really, really close right here. So we can tell the axis of symmetry is x equals 1/4. That's the vertical line through there. It's going to turn around, go back up. So at 10 1/4, or at x equals 1/4, it's going to be back at negative 10, right? Or x equals, sorry, 1/2 would be right back at negative 10. Good times. I don't know if you hear my gardeners, if they're mowing my lawn right now, so if I seem distracted, that's why. I apologize. Anyway, let's move on. So we've got the vertex, the y-intercept, the axis of symmetry. We need the x-intercepts. X-intercept is where it crosses the x-axis when y equals 0. So let's just solve the quadratic equation. 2x squared minus x minus 10 equals 0. Should we factor it? Should we do the quadratic formula? Well, a is 1, b is negative 1, sorry, a is 2, b is negative 1, c is negative 10. We could do b squared minus 4ac would be 1, right? Negative 1 squared is 1, minus 4 times 2 times negative 10. That's 8. One plus 80 is 81, and that's a perfect square. What does that tell us? That tells us we can factor it. So let's factor this. So how do we factor? Diamond, rectangle. I don't know how well you can see this, but I'll tell you what goes in where. So we've got a times c is negative 20. So I need two numbers who multiply out to negative 20, add together to get negative 1. How about negative 5 and 4? That works. Let's make the rectangle a little bigger. So here we've got 2x squared, negative 10, negative 5x, 4x. All right, let's work it out. What goes in where? What's the GCF? GCF of 2x squared and 4x is 2x. We get 2x squared, we'd be left with x. GCF of negative 5x and negative 10 is negative 5. GCF of 4x and 10 is 2. So I get 2x minus 5, x plus 2 equals 0. So using the zero product property, we've got 2x minus 5 is 0, x plus 2 is 0. Well, if x plus 2 is 0, x would be negative 2. If 2x minus 5 equals 0, x would be 5 over 2, or 2.5. So there we go, and it's going to come up and down, turn right at that vertex, Go back up. And if I could draw well, that would be perfect, but I did not, so I'm going to try this half again. And that looks better, doesn't it? All right, so there's our graph. Those go on forever. Axis of symmetry, x-intercepts, y-intercept, vertex. We got everything. And that's it. Does everybody see how to do it? Okay, so once again, to find the x-intercepts, we factored. If it didn't factor, quadratic formula would work. There you go. Axis of symmetry is the x equals the x value of the vertex. Vertex, x equals negative b over 2a. Solve for y. Y-intercept was easy. Just C there, and you got it. All right. Thank you for listening. I hope you learned something. I hope that helped. Any questions in my class, ask in the discussion section. Somebody else's class, ask your teacher. They should be able to help you. All right. Thank you guys for coming. Take care.